For today's lesson, we are going to be evaluating expressions. This is lesson 3.1 in algebra. So a couple of vocab terms to talk about here. An expression is a mathematical phrase that contains operations, numbers, and or variables. But the point that I really want you to remember is that it does not have an equal sign. Numerical expression is an expression that contains only numbers and operations. So for an example here, I put 2 plus 3. And then an algebraic expression is an expression that contains at least one variable. And my example is 5 plus x. And then coefficients. Coefficient is definitely a word you're going to hear a lot from now on. It is that number in front of the variables, the one that's being multiplied by the variables. So my example here, I put 4t and negative 3x. The coefficients would be 4 and negative 3. So identify the terms and coefficients in the expression 4p plus 5 minus 3g. Well, the terms are what is separated by the adding or subtracting. So 4p is its own term, so that's one term. That 5 is a term, and so is that 3g, or negative 3g, because that minus sign really is a negative sign. And then the coefficients, we only have two variables in there, and the coefficients are the ones being multiplied by those. So I have a coefficient of 4 that's in front of the p, and negative 3 that's in front of the g. And then my next question, what is the coefficient of the n in the expression n minus 9? Well, there's not a number out there, so it is a 1. We have one n. We don't have multiple n's, and we don't write the number 1 in front of our variables. So whenever you see just a regular variable by itself, the coefficient in front is 1. The order of operations we have talked about for many years is also known as PEMDAS. And PEMDAS, as you can see, if you go down the left-hand side here of this chart, is the first letter of each operation or each thing that we have to take care of in the order of operations. And it starts with P for parentheses. So you have to go through and simplify what's inside of the parenthesis. So that is what is done here in the first step. We had to do that 9 minus 6, which turned into a 3 over here. Then next is exponents. So the only thing that had to be done with an exponent was the 4 squared that got turned into this 16. Then we have multiplication and division, and you have to do those in left to right order. And I only see multiplication here, and that was done, this negative 5 times 3 turned into this negative 15 here. And then addition and subtraction are last, and again, those are also left to right. So we had 7 minus 15 plus 16, so we just go in that order. 7 minus 15 would give us a negative 8, and negative 8 plus 16 would give us a positive 8 for our final answer. Our next question here says to evaluate the algebraic expression n times the quantity of 5n minus 13 to the third power for n equals 3. So we have to plug that 3 in for every n that we see in this problem. So we're going to have 3 times the quantity of 5 times 3 minus 13, and then that's to the third power. So we have to go through the order of operations. Order of operations starts with parentheses. So inside of the parentheses, I have 5 times 3, and then I have minus 13. So that's really 15 minus 13, and that would give us an answer of 12. Sorry, not 12, 2. 15 minus 13 is 2. And then I'm just going to bring down what is left over. We have 3 times 2 to the third power. Then we're going to go through And next on our list after parentheses is exponents. So I have the third power there. So I have to figure out what 2 to the third power is. And that just means I have to take 2 and multiply it by itself 3 times. So 2 times 2 times 2 would give us 8. So that would simplify down to 8. And we're still going to have this multiply by 3 out here. And then next on our list is multiplication and division left to right. We only have multiplication left in this problem, so we are just going to simply do 3 times 8, and we get an answer of 24. So your turn. I put 2 examples out here. I would like you to pause the video and try them out and see if you get the same answer that I do, following the order of operations PEMDAS. So 7 times x, and they tell us x is 4 and y is 7. So we're going to actually have 7 times 4 here, plus 3 times 7 for y, minus 12. Parentheses, the only parenthesis I have here is to show multiplication. There's nothing inside of them to simplify. Next would be exponents, and I don't have any of those. And then after that would be multiplication and division from left to right. I do see some multiplication. I have 7 times 4, and I also have 3 times 7. So 7 times 4 would be 28, and 3 times 7 would be 21. And we still have that minus 12 at the end. And after multiplication and division would be adding and subtracting, and again from left to right. So we are going to add the 28 and the 21 together to get 49. And then we have to take 12 away from that. And when I take 12 away from 49, I am left with 37. And then for this problem that looks just a little bit different, we are going to again plug in the x, 4 for the x and 7 for the y. So we're going to have 2 times 4. And then inside the parentheses, we're going to have 3 times 7 minus 4 times 4. And I'm going to put a second set of parentheses there to close because this right here is just around the 4. This is the opening and this is the closing for this other one. And then squared. So going through order of operations, we have parentheses. So inside the parentheses, I have 3 times 7 minus 4 times 4. So that would be 21 minus 16. And when I do that, I get 5. So this whole set of parentheses there simplifies down to 5. And then I'm going to bring down the squared, and I'm also going to bring down that 2 times 4. Now we've taken care of parentheses. Next is exponents on our list. So I have 5 squared. 5 squared means 5 times 5, which is 25. And we have to bring down that 2 and the 4 as well. And after exponents would be multiplication and division from left to right. So we just have multiplication that we have to take care of. And 25 times 4 is 100. And 100 times 2 would be 200. So the final answer here would be 200. All right, another example. Sheila is riding in a multi-day bike trip. Each day she rides a different distance in a different period of time. On the first day, Sheila rode 100 miles. So for part A, on the first part of the trip, Sheila rode for 6 hours and covered 75 miles. Find the average speed for this part of the trip. Use the relationship D equals R times T, which stands for distance equals rate times time. So our distance, if we look, they told us she covered 75 miles. So that's going to be our distance. And they asked us to find the average speed. Well, our speed is our rate, so we don't know what that is. So I'm going to leave that as an R. And then that's going to be times how long did she ride for? And it told us 6 hours. So then we have to solve this equation for R to figure out how fast was she going. So we are going to have to get rid of that multiply by 6, and the opposite of multiply by 6 would be to divide by 6. So if I divide both sides by 6, I'm going to have 75 divided by 6 on this side. 6 goes into 7 once with 1 left over. Bring down that 5. 6 goes into 15 twice. That would be 12 with 3 left over. So our remainder is 3. Our denominator would be the 6. 3 6 reduces to 1/2. So this would be a 12.5. And if we look back in the problem, looks like miles and hours is what we were talking about. So Sheila was riding at 12.5 miles per hour on her bike trip. Our last example here is on the second day of her trip, Sheila rode at the same average speed as the first part of the trip, first part of the first day. Her total distance over the 2 days can be represented by 100 plus 12.5 t, where t is the number of hours Sheila rode on the second day. Sheila rode 7 hours on the second day, so find the total distance Sheila rode in 2 days. So we're going to have to plug in 7 for that t, because it told us t was the number of hours, and then it told us she was riding for 7 hours. All right, so 100 plus 12.5 times 7. Adding and multiplication in this expression, so I have to multiply first. So 12.5 times 7 would be 87.5. And we have to add 100 to that, and that would give us a total of 187.5 miles for her total distance in her 2 days.